HGTV viewers, 2013 is here and it's time for you to get to all the projects you've been putting off all year. Get out there and get something done.
Guys, I have a great idea. I saw this on TV. I want to make this room into a library. That whole wall right there, I want to make it one giant bookcase. But it's so tall, I don't know how tall to make the bookcases. Do you think you guys can help me out and figure out how tall that wall is?
Oh yeah, let's do this.
Okay, great, thanks. When you get it done, just let me know and then I'll order them.
Yeah, thanks. So, how are we going to climb up this wall?
I have no clue, but maybe we can measure it.
That's kind of weird. See if we can get up there. Oh, where are we making? Ah! That didn't work. Alright, let's see if we can climb it.
Right. I got this.
There you go. Dude, don't lie. That's not gonna work.
No, hang on, I'm almost there.
Dude, we should go to REI. Get some climbing gear.
Well, if you think that'll work.
Hey Mom, can we go to REI?
Sure!
Hey man, let's go get the keys. Come on, let's go.
Woo! Hey, how are you doing? When did Grayson get his license? He didn't have his license. Why? He's out driving. I said he could go to REI. I didn't say he could drive. Oh my goodness.
Good idea.
Oh yeah. Well, let's go check out.
Hey, what are you two doing?
Trying to climb a wall and find out how tall it is.
Well, instead of climbing it, why don't you just use map?
Oh, that's a good idea. Let's put this up. No, that won't work. Polygons not really going to help us with interiors. Postulates and diagrams. Don't feel that's going to help.
Are you having trouble finding the height of your wall or telephone pole?
If so, then use section 7.3 in a local geometry textbook. It is an easy and accurate method. Try it on your wall today.
And in a related story, it seems that teachers are doing cartwheels in 2013. It only takes an 85. Back to you, Jane.
Why would you do cartwheels? Alright, so the TV said that we had to use chapter 7.3, which uses similar right triangles. So theorem 7.5 says, if the altitude is drawn to the hypotenuse of a right triangle, and the two triangles formed are similar to the original triangle and to each other.
Hey, this is Theorem 7.6 says, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is geometric mean to the length of the lengths of the two segments.
Kind of makes sense. Theorem 7.7, the geometric mean theorem, states, in a right triangle, the altitude from the triangle angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is a geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the left. Man, that's a tongue twister. So, in chapter 7, I had a little bit of a hard time in chapter 7.3. I got a little bit confused on how to set the formulas up for the triangles. I got a little bit confused on, it was supposed to be the short leg or the long leg going up on top, and I figured out how to correct it by just going back through my geometry textbook and just reading it over and over again. So now I figured out how to solve this problem. I'm just going to go and try out the wall now. So, and since the wall is a lot taller, I'm going to make the picture a little bit smaller. So, here's me. My angle to the ground, and then the wall, since it's so big, the angle to the wall. Make a 90-degree angle, cut it across. Alright, since I'm pretty sure I haven't grown in the past couple days, it's pretty safe to say that this is still 67. Now, the distance across has changed, because I did have to go farther back to be able to see both the top and the bottom, since it was a lot taller. So, the new distance is 137 inches, which is pretty far, I guess, especially if it was in feet. And then I'm going to name this little part right here W, because you guys probably remember how I got to that last time. So the equation would be W over 137, because the two legs, equals 137 over 67. So this time W is going to be bigger than 137. So you have 67W, which is quite a lot of W's, equals 137 times 137. And if you multiply those two, 67W equals right around 18,769 inches, which that is quite a bit. I'd like to make that number a little bit smaller, so I'm going to leave W by itself by dividing both sides by 67. W will now equal 280.13. If you add 67 onto that, because this is just W itself, you add 67 to get W equals 347.13. So I'd like to get this into feet, just because most people wouldn't guess, oh, that wall's, 153 inches. They usually tend to go more towards feet. So I'm going to divide this whole equation, 347, by 12, because there's 12 inches and a foot, and it comes out to right around 28 feet. Hey, Pops, how tall do you think the wall is?
Probably about 27 feet, 25 feet, something like that.
So yeah, we got pretty close. And the math book does say that it's approximate, not exact. So 28 feet is approximately the height of the wall. Thank you.
We did it.